Okay. So we're talking about the DLAB14, right?
Mm-hmm.
Okay, last time this first part of the DLAB13 or 14, the guy already did it, right?
Mm-hmm.
Very close. Just a minor change.
Mm-hmm.
So that's why you need to correct to make sure the first part has to be working. Okay? If you get any question, and just let me know. I will be happy to. Okay? And you can see another lab will be using the same ICU4. That will be a PIO, basically on your computer, on the computer using that IC. Okay? Only thing is now they will be much better. More output, more input, more function. Now in here we already learned the basic, very basic. That means HIC they get 3 port A, B, C. And A or B or C they can sending out data, or they can reading data back. And they get that one here. That's the data bus. Data from here can go to A or B or C. Or data from A or B or C can come in here. However, before you want to do anything, you have to send what we call a control word, right? Telling, okay, I want A out, B out, C out. Then now you can send data out. Or you want X1, get it in. Then you can say, okay, A out, B in, C in. And you can read data from port B or port C. And that's what we already get for you. Okay? In my program telling you, you write to port A, U4 port A, right? Or you reading U4 port B. Everything I already did for you. Okay? Today, first thing I try to see, the Zoom can be review, record or not. And after that, I see how they're coming out, look okay. That will be telling you in the next time you're not here, you still go to the Zoom. Okay?
Is it recording it?
Yeah,
oh, yeah
right now,
is. Okay.
Still recording.
Yeah, I see it. I see the little.
Then that's what I want to see. Okay? Is it recording working?
Yeah.
Then next time, okay, we'll be doing it good. Now, go to the second part. Okay, this is the D to A converter. Okay, this circuitry will be everywhere. You can see. The thing is in your phone, when you're talking, that's the voice signal. Computer cannot recognize anything else except binary. Okay? Computer only know 1 or 0. At it, they don't know anything. So, your phone, they have to get this circuitry. The thing is, when you're talking by your voice, analog signal. Okay, so this circuitry will be the binary digital 8-bit. When they go to that one, they will be converting to the analog signal. That's what they call D to A converter. Your phone is not 8-bit, 24-bit at least. Okay, that only thing the difference between the bit. Okay, it's not different the way they're supposed to be working. So that's why you have to try to understand this circuitry working. That will be help a lot for everything. Now, first thing you see, this is using the power. Pin 13 is 12 volt DC, and pin 3 will be minus 12 volt. First thing is, they adding that one, okay? That means they want the output of U9 supposed to be 10 volt. And that's why they connect input to the resistor. You can adjust. Okay? What happened? You connect your meter into U9 pin 3 and try to adjust the port here until you get 10 volt. Okay? And why they need 10? The thing is, this IC, they need 2 milliamp as a reference. Okay? So now, if you look into the circuitry, pin 3 here, you get 10 volt. And a pin 14 here, what do you think the voltage you're supposed to get? Zero. Correct. The thing is, 10 volt divide 5K. That's why you get 2 milliamp. That will make the IC working. Okay? And the IC try to apply signal binary here. Okay? If you say 1, 1, 1, 1, 1, 1, 1 on 1. So that means the maximum. Then you add pin out, pin number 4 coming out. That will be coming out by current, not voltage. Based on the current coming in here, 2 milliamp. So now, if the current pin, I add pin 4 current coming out 2 milliamp, and basically we don't deal with the milliamp. You see that? You not measure milliamp. At work, same thing. The thing is, when you try to measure the current, you have to break the circuitry to let the current go through the meter. Okay? That's not allowed, even here or at work. Okay? So that's why we have to add in the U10. What U10 name? Who knows?
Op-amp.
Op-amp? No, that's just general. Op-amp just a 7441. However, I want to know the name of that circuitry. What that circuitry name? Who knows? What?
No, is it measuring meter?
Okay, I tell you. You coming in is current. You coming out is
Voltage.
voltage. That means this circuitry will be current to voltage converter. Okay, we don't deal with the current, so we need to add this circuitry so they converting to the voltage. So that's why. And now you can see current coming out 2 milliamp, they go to 5K. 5K times 2 milliamp. Output here will be pin 6, that maximum will be 10 volt. That's how the circuitry working. Okay? So the first test on this one, I say I want the input will be AA. Okay? That means 1 0, 1 0, 1 0, 1 0. And the current coming out here, pin 4, just a half. Basically, they multiply 5K. If you measure U10 pin 6, around 6 volt, that means circuitry working. Okay? So when you test it, then normally that is the one you have to check when the test fails on this test, and make sure you get U10 pin 6 have to be 6 volt. Not something we don't get. Now, get any question up to this point for this circuitry? If you see the connect pin 2 round, pin 1 round, okay? And this connect capacitor to pin 16. That's the way for the circuitry working. Any question? Anything? No. So that's very good. Now, this is the second one, the last one. So basically, this will be connected into the output of U6. Okay? They say U14 pin 6, U11 pin 6. That's telling you you get 6 volt right here.
Is that U11 pin 6?
Yeah,
Or U14.
14.
Okay.
That's why I need to correct that, but go back here. U10 pin 6.
So it's
So it's supposed to be
U10.
U10.
Yeah. That's supposed to be U10 pin 6. That's only telling you. If you get U10 pin 6, okay, they're telling you connect to R4 pin 1. That's what you see. They say connect to R4 pin 1 left. So basically will be U10 pin 6 instead U14. Sorry. Okay. Now you get 6 volt for input AA. Next, what the voltage at U11 pin 3?
Should be 10.
How many volt?
10 volts. The same.
Who knows? Okay, I tell you. You see 10K, right? This is 10K. Divided by 2. Right? Divided by 2. Okay? So 6 divided by 2, U11 pin 3 is supposed to be 3 volt. Okay? 3 volt.
But isn't the U10 supposed to be 10 volt because line of 6?
Okay, you're talking this one, right?
Yeah. Or
U10 pin 6.
should be 10 volts.
Now,
6 volts?
6 volt, the thing is 10 volt if you apply 1. Now I say we apply on the left. I want you to do AA 10, 10, 10, 10. And this supposed to be 6 volt. Okay? And that 6 volt connect to R4 here. And voltage divider U11 pin 3 supposed to be 3 volt. If you apply on one input, you get 10 volt. Then this will be 5 volt. Divider. The thing is you have to understand. So why they're not working, you can troubleshoot it to fix it. If you measure right pin 3 here, they're supposed to be 3 volt. They're not. Then you can measure R4 pin at the left. They're supposed to be 3 volt. Okay? If they're not, that means the connection from here to U10 get a problem. If they do, that means resistor R4, R5 get problem. They must be 10, 5K. And that's just a voltage divider. Okay? Divide by 2. So the circuitry U11, what is the name of that circuit?
Analog converter to digital.
You mean
Analog to digital converter.
no.
Or the
Right here, analog, right? 3 volt. Analog.
To digital, right?
No, not digital. Pin 6. What pin 6 supposed to be?
Wait, what was the question? I'm sorry.
What?
What was the question?
What is U11?
U11 pin 6.
U11 is another 741.
That should be.
So it's a converter. You just told us what it was.
Sorry.
It's an amp, but
That
it converts
unity gain
current.
amplifier.
Say it again.
Unity gain amplifier. That means input, output, the same.
Oh.
Okay? Unity gain amplifier. That means you forgot that amplifier. Input, output will be the same. The gain is the 1. So basically, U11 pin 6, 3 volt, and U12 pin 6, 3.
Now, why do you need a U11? Since it's gonna be, it's just like a safeguard.
Now we make sure, this signal is not screwed up. So that's why they're using the amplifier. And the other thing, who tell me why I need capacitor?
To make
C3.
it steady.
Perfect. The thing is when I designed that one, basically, we did already in my company at that time. Okay? This circuitry, I looking into that. I try to see how they have to do. Okay? That's why. This capacitor try to guarantee the voltage here will be stable.
And U11 makes it even more stable.
Exactly. That's what they want. Okay? And for U number 12, that will be ADC. They converting analog 3 volt to the
Digital.
binary.
Oh.
Okay? Convert to the binary. And whatever they show here, pin 25 volt, this pin 7 ground, 8 ground, not connect pin 9. Okay. And make sure ADC U12 pin 10 must be round. Okay? Just a DC, just a digital. They get power, they must be get round. Okay? It's not so you here, but that you have to make sure you connect pin 20 to 5 volt and pin 10 must be round. And in here, okay, pin number 5, before they connect to the round, okay, so we correct that, we're telling you, pin 5 connect to pin 3. The thing in the past, we get a problem. They're not stable. So that's why we have to find a way to fix it. So only pin 1, pin 2 round, pin 5 connect to pin 3. That's what we're telling you here. And if you're looking into pin 19 and pin 4, okay, pin 19 will be clock read, pin 4 clock input, okay, and that is the way they connect. So if you're looking into pin 19 or pin 4, you can have to using the oscilloscope. They will display the signal. Okay, you can see the clock. They will be display the signal. Okay, and after they working okay, they convert into the binary here. And that binary go to U13 541, just a buffer. Buffer, okay? If pin 1 and 19, 0, they will be go to U4 14. That means they will be connected into port C. Okay? Now you want to verify. You have to reading port C. And that coming out here and will be verified here. Yeah.
So the PA, PC, and PB, are they both inputs and outputs?
Yeah, that's what I said.
Oh.
You want out, they out. You want in, they in. However, before you want to using this IC, you have to send controllers. Okay? Quickly, I will telling you. Okay, let's see. I try to get this one.
Or
You
A?
gotta go to the, I think A,
4A.
column A.
4A. One more.
There you go. If you go up to the dialogue box, you probably have better luck. You
Yeah.
know, yeah, the white.
Just a minute.
Okay. It's difficult when they're that big.
Huh.
I had to shorten it, and then it took me there.
I don't know. On that one, then not
Just,
working.
just take out Chrome extension, take it out.
Yeah, you have to take out the Chrome extension.
Chrome extension, take it out and just copy the rest of it.
Yeah,
Okay. So you tell me come back here, right?
Yes.
Copy from here or where? Or
No,
copy
no, no, from
everything.
there.
Is it okay here?
Start from here. From here,
Ah, let's see.
when it says HTTP.
SP, okay, right here, right?
Yes, from there all the way
Yeah.
up to here. And then just paste it.
do it up
Just
in
copy.
the dialogue box. It'd be easier, in the white box, up above, up above, up above,
Here.
up above the sheet. Okay.
Say on top.
Yeah. Let me see. Thank you. Oh, you got it?
Okay.
Did you get it?
Yeah.
Okay.
Copy.
Now you've got the J.
Whoops. Okay. That's,
You gotta remove the J out.
yeah, that's fine. We can get rid of that. Here.
Take it as a sample and J.
Better. Yeah, so that we know. Do that.
Oh, there it is. Okay.
Yes,
There you go.
Wait, that's not yet.
That's really weird.
Yeah. Where's the thing? Yeah, I'm not wearing the right glasses to be doing this. I have to buy the glasses. I can't see a thing. Thank you. I shortened it.
Yeah, just take that one out.
I
There you
took
go.
up, yeah.
There you go.
And then
Work fast.
Crash this.
Okay, so that be
let me-
Forget
let me go there and see
We'll
what
try.
the problem is.
sometime.
Let me see.
This thing, right?
Yeah, exactly. How come on this computer we cannot get it? Before I saw, but maybe not in this computer. Maybe on the other one, in the other room, or in my house, I don't have any problem.
Okay, so. Oh, yeah, it is another thing. There we go. Okay.
Or you can just type in.
You can just type in 8255.
Yeah,
It'll
there it
take
is.
it straight up.
Okay, you get it. Thank you. You're very good on the software.
I'm not.
Okay, so basically, if you get more information, you can go to Intel here. Okay, I just try to telling you the basic. And this basic telling you, okay, basically port A go to a data bus. Okay, so basically you want to reading, okay, reading 0 means you read. Also A0, A1, 00, A, B, C. Okay, they're telling you, okay, you want to read or you want to write. Write means a data bus go to A, go to B, go to C. Okay, and when you get one write the control, okay, that means you have to using that in the program I already given to you. You say write control 0x89, 0x00, for example. That just follow that, then you can write the control. That's what they call a control word. Okay? And they read everything. Which one you want? Now, this is a table. Basically, they get more if you go into here. I just try telling you. This is the control 1000. That means 80. That means you want A 8-bit out. C 4-bit out. 4-bit out. 8-bit. B 8-bit out. So depending on in or out, you have to looking into the control word here. Now, I'm giving you other one here.
All the variations.
That will be 81. Okay? That will be telling you what? 8-bit out. C 4-bit out, 4-bit in. And B 8-bit out.
It's so interesting how many different variations that are actually possible.
They can do a lot of things.
No kidding.
That means for port C, they can send 8-bit, 4-bit out, 4-bit in.
Yeah.
Also, they can send the signal out and in. Okay? That's a lot of work for that.
Yeah.
It I see a very, very good one. Okay? See a lot of difference. See that? This control 81010 8A. Right? That you want A out. C first 4-bit in, next forward, out. And B will be in. That means depending on the control word, they can telling you which output will be in or out. That is the first thing you must be doing before you can apply data. When you understand, that's very simple. Okay?
I have questions. What is a control word?
Oh, that means inside the IC. When they receive that control word, they know how to set it up with port in or out.
So it's a command.
Yeah, inside. Instead, before you doing the digital lab, maybe 10, 11, okay, we're not using this IC. So that's why you have to using the other part, okay? One handle out, one in. Now this substitute for almost of the circuitry. Inside that IC, they did it. Okay? If you get the time, you can reading data for this IC. You can understand more. More things they can do. The thing is inside a lot of things. Okay? They try to combine everything, put into a one IC. That can save time, save, the play inside the circuit.
Instead of using too many ICs,
Yeah,
everything is in just
right.
one IC.
Inside. So that's why later on, you can see now, every circuitry,
It's gonna be
they put inside one IC. Okay? That means save the play. Okay? How come iPhone before it big, now it's smaller? The thing is, everything they put only one IC. Okay? So that can save a work play. Okay? Okay, so basically this circuitry I have working perfect. Okay? Only thing is your job. The part I say, let's see, where the program.
That's what I'm talking about. I know.
Okay, this is a function for ADC test. So to me, this one, okay, you just using that. Water. Okay. Only thing is you can see when you start it, they're telling you connect. That's what they're telling you. Okay. Adjust L9 pin 3 for 10 volt. Okay. That's what they're talking here. U9 pin 3 10 volt. And now this one, they loading data, okay, in ADC into the memory. That is a loop, okay, write AC data to memory address, okay, whatever they're doing. Then okay, on that one, that number equal that number. The thing is that number here using for analog. Okay, so they have to be equal that number in the program. That title, expect value, you want 6.64, tolerance 35%. And they say apply memory address 40. Okay, read memory. And they're using U7 clock. That means U7 clock connect into U number 8, U7. That means in here, U7. That connect to the memory output, and that will be 74374. You apply the clock, they will be go to the output here, and that output will be go to U8 input. That's why they say apply U7 clock. Okay. The thing is when I troubleshoot it, okay, then I go to U7 clock. Okay. I'm telling you quickly. And the last one, enable ADC. Enable ADC. That means pin number 3. You add pin number 3. Okay. Go up and down. That's it.
Can you repeat what you just said?
What?
What did you just say?
I just said
Pin
pin 3.
3,
U12 pin 3.
U12.
That's what I use in enable.
Okay.
Enable ADC. That means you can see enable ADC. That means they apply high and low. Okay.
It's not open yet.
Oh,
I don't understand.
I don't think, is it open?
Yes, I try to open.
Hmm.
Normally, when I click on that,
Double click on it.
okay, it's supposed to be open.
Go
Yes,
to
the
view.
project.
Go to view.
View,
Go to view.
Auto view.
All the way up.
and
To the left hand side.
over on the left side, up top. There's the second thing next to file. File, edit, view.
View?
View, yeah. There's an explorer.
What is it here?
See? Oh, it's what is it that the license is gone. It's weird.
Okay, put that there. Double click.
I don't know.
There.
I got it.
Sorry.
Oh, that's it. Oh,
That's what yeah. Do that in the morning.
Need to pay for it.
4 hours per day. Is it? 18 months.
Why they're not doing anything?
You said something about the license and it's expired. That when you move out.
See, it means this, that something's wrong with your license. They need to be update your license in order for you to use it.
See,
Maybe only this computer, I don't know. So it won't let you do anything.
okay, I see.
See, maybe if you enter your password, maybe it'll work.
Times that by 3.
If you go
No.
here, close it,
3 days.
What?
close that.
122.
Not going
So
up.
who do it?
I don't know.
right.
I don't know either.
2 weeks.
But if you go here, check for updates.
2,
I don't know who's that.
I don't know either.
no, 720.
Just close it.
Then you just deduct the taxes. It should be around.
It won't let you do anything, huh? There you go. See, check for updated license.
Times that by.
Number, like there's 2 lines.
And you want to know by the year.
It says to enter your password, but who's that?
I don't know.
That's weird.
That's weird. Okay, that's okay. Tomorrow I talk to Mr. Ty. Take care of me.
Yeah, that's what it means. That's why it won't let you do anything.
Okay, I know.
Yeah, I'm still learning, I'm still learning. But
All right.
I do know,
Yeah, always has
I've
more.
been reading the IC packet. You know, that's been.
He always has more.
Okay, anyway, I don't know how come they get the problem. On the other room, no problem.
So we have a lot of work to do on the coding, right?
Right,
Oh, boy.
okay.
That's already been used.
Tomorrow I will let the other instructor take care for me.
Okay.
Yeah,
Are you
they-
coming tomorrow?
No. I got too many things else to
Okay.
do,
Oh,
okay? Only thing, you get any question or confusion, take to me.
Okay.
You want online. I'll be online with you, no big deal. Okay? I try to help you to understand. That is why will be keep your job will be very good. Who can understand whatever we did here? you can see from left volt, right, up to digital fundamental. A lot of things to be good, basically electronic technician. And you guys, job, keep going. I'm sure someday you will be engineer. When you go to USC, University of San Diego, no problem. Okay? Especially at the time. Why? They did almost everything online. See that? How come? That's why you can work at home. You just turn in all of the requirement. And you're okay. That's how come my two students last 1.5 years. They take just a 1.5 years and complete the program for electrical engineer. But they work really hard. Okay? But don't have to be much goes into the school. So that's why I say this is a very, very good time to get a degree. Okay? So you get any question to me? Say you're doing very well to me. You know much about everything, right? That will be help a lot while you go to the university. Basic electronics you already know. Basic digital software you already know. Up there they're still using the same, but they cannot use it like we did here. The thing is, the one we did in here coming out from my company. I'm working in my company. So that's why I want to get really for engineer to know to bring it to the school. Okay? The thing is, I don't want to take for technician only telling you how to do that thing. Okay? You're using the scope, you're using the meter. Okay? Follow that and try to do for the left volt. Left volt just the basic for understand the electronics. Normally take at least 2 years to get through left volt. Okay? And that also cost too much. So no school try to get it by that equipment like we get. Left volt, circuitry board, everything. That cost a lot of money. We are lucky. The thing is, at the time, I get one lady, American lady, she a dean of this program. And she get a very good way to collect money somewhere. And at that time, she coming into this program almost every half month to see what's going on. And we're doing very good and working very hard. So that's why she put a lot of money to buy left phone system, over 100,000. Also on the computer, get 60 computer new. Also CRT, everything new. So we're lucky we can get that. I ran this program for 42 years, but I just go up around 15 years ago. Before we cannot get enough equipment. Everything is really old. Okay? That's not good. So it's very good for this program. However, I want you to get up into engineering. Okay? That's not for you. For your family, for your kid. If you're working hard, take you 2 years. Maximum. That's what I already did. Okay? Any question? Anything? You see that in here, I teaching for technician, but the level is different. Asking for your understanding. In order you can do a better job. Okay? Any question? Anything? So, right, you can get today, we still get time. We got today, tomorrow, Wednesday. Time to see who can get it done. Who can get it done? Let me know.
Okay.
Okay, as I stop this Zoom to say, you know, we can record it or whatever.
This connects to E520. It tells you